The demo runs on Kubernetes cluster with Cilium Enterprise Edition CNI, configured with multiple IPAM, BGP control plane, as well as L3VPN SRv6. The reason for prototype is that multiple IPAM and L3VPN SRv6 is not currently available in the official Cilium EE and it's not part of the roadmap. So I've made the change in the code to enable that combination. The kube cluster is connected to SRv6 network, starting with the top of the rack type of device called P5, and then we have the core routers and PE routers to which the CE devices in red and green VRF connect to. As you know from other recordings, Kubernetes cluster nodes behave as SRv6 PE, L3VPN PE devices from the network perspective. The kube cluster is enabled with kubevirt, so the deployments that will be running in this demo are virtual machines, and I will also show live migration. Interaction with the kube cluster will be done via the custom GUI, and here we see what are the pod IP pools deployed on the cluster. Of course, we have the default one, 10.1/16 and corresponding v6 subnet, and from the default pod IP pool, each node gets its own v4 and v6 siders for the pods. I have also pre-deployed 3 different pools, and which will be used throughout the demonstration. Before starting the demo, let's also check the state of the network devices. So we have BGP enabled from the kube cluster nodes towards the top of the rack device for v6 underlay and towards the route reflector for v4 overlay. Locator pool is created, and every node in the cluster gets its own locator out of the pool. VRF is also already configured, and in that VRF we have the seed based on the locator and function on every cluster node for that VRF. And as the result of the configuration, the pod siders of the cluster nodes should be BGP advertised, and via route reflector make its way to the red and green VRF. Actually only red, because only red is configured. So if I go to, for example, to CE11, which is the VRF red device, and I check show a route, we see that we have over BGP learned the 4 pod siders from every cluster node. In the first demo, I will create the VMs in pool 66, which is quite large pool, meaning that it's /24 with mask 28. Several nodes can get subnet out of this pool, and also several subnets can be allocated to the single node if needed. So let's see that in action. I will create virtual machine in that pool, and I will create 6 replicas of them. I will make them part of the VRF, and at this stage I will not create any service. So what's going to be pushed via the kube CTL is the virtual machine definition. So every VM, 6 of them initially stopped, and then each VM is annotated with the pool, as well as has the label that makes it part of the VRF. And the rest is the classic virtual machine definition for basic Cirrus VM. Since the VMs are created but not yet started, nothing happens from the allocation perspective. We need to start the VMs. So I go to a different page. We have all the VMs that I have just created, and when I hit the start button, all of them will be started. From the VM perspective and kubevirt implementation, the virtual launcher pods are created, scheduled on the cluster. They will get an IP address, v4 and v6, and that IP address will be pretty much the IP address of the VM itself, because the VMs are configured to connect to pod network in masquerade mode. So the IP address allocated to the VM, to the pod, virt launcher pod, will be effectively the IP address of the VM running inside the pod. We already see that scheduler have selected different nodes for different VMs. So let's go back to the pod IP pool page. And we see that since the 6 VMs are equally load balanced across the cluster nodes, 3 worker nodes, then every node will get /28 out of the pool. That confirms the behavior of how multi-pool IPAM works, also in the context of the virtual machines. Let's have a quick look also at the CE. We see here the subnets. Those subnets are the ones from multi-IP pool. So they are BGP advertised, and we have end-to-end connectivity. In the second demo, I will create the VM in XXX pod IP pool, which is quite small. It's /31 with mask 32, meaning that this pool can have 2 subnets, each 32 with 32 mask size. So let me create a single VM in that pool. I will also make it part of the VRF, but this time I will also enable SSH service onto that VM. Taking a look at the definition, some things are similar as before. So VM initially stopped, annotated with the pool, labeled with the VRF, and then the service is also labeled with the VRF, and by the selector is associated with the VM. So let's create that. So let's go to VMs. Then I will start it. That VM is scheduled on kind worker 2 node. And effectively it's got the IP address out of the pool, 10.66.66.65. Let's wait until it's up and running. The pod and the VM should be operational by now. Let's check how it looks from the CE11 perspective. So we've got 2 new BGP advertisements. One is for the pod CIDR, the one that has been allocated from the pool for that VM. So that's /32 because the mask size on that pool was /32. And we also have a service IP for SSH service, also BGP advertised, part of the VRF. Take a note at the time, pod CIDR was before, service was later. The reason for that is that the service will be advertised only when the service is detected to be functional, endpoint is working, etc. So that's why there is a small gap between the pod CIDR advertisement and the service advertisement. So in order to check further, I will go to CE11. It has the following interfaces, and I need to SSH from that interface to Cirrus VM from the routing perspective. So let me do that. Okay, we are on the VM. It has been booted recently. It has an IP address in masquerade mode, so the IP address you see on ETH interface is not exactly the same like you see from the virtual and pod launcher perspective because it's pod masquerade mode. Let's also touch a file that we see that we have some file created on the file system. And let's just leave that session here running on from the CE towards the VM. And let's perform migration of the VM. Right now the migration has been initiated. Let's observe first how it looks like from the multiple pod IP perspective. We see that the way it works in kubevirt is that a second virtual launcher is created for that VM. It will need to be scheduled, definitely on different node because we want to migrate the VM. And that virtual launcher, that pod, will need to get an IP address. It will get an IP address. This time you see it got 64/32 on different node. It was possible due to the way the pool has been defined. The pool was /31 with mask 32, so I could allocate 2/42s out of this pool. That's what's happening. The second pod has been created. There is some some processes going back and forth to copy the file system, memory, etc. How live migration is working. When it's completed, the VM will effectively migrate to a new location. It will be running in different pod launcher using different IP address. So from the pod perspective, the IP address of the VM has changed from 65 to 64 within the pool defined here. And if I go to the console, I'm still here, right? It has not connection has not been dropped since we are in masquerade mode. Our IP address is exactly the same. We still see the file system uptime has increased, so that confirms live migration in action. I can also create a VM in sticky, so-called sticky pool, which allows me to only allocate /32 IP address on the single node. Let me create that right now. That will work perfectly fine. Scheduler will select a node where the virt launcher pod will be created. It will get an IP address from that pool, /32. The VM will run inside of it. However, any attempt of migration of that VM will effectively fail due to the nature of how migration works in kubevirt. The kubevirt will still try to create a second pod launcher on a different node, and that pod launcher will actually wait for an IP address. It will not get this IP address, right? Because the pool is /32 with masks 32, so I can only lease from this pool a single IP address at a time. I forgot to start the VM, that's why. But it will definitely work in this context. So you can go down to even /32 sticky IP address, if you will, for the VM. But keep in mind that live migration in that situation will not work. If you want the live migration to work, you can go as low as /31, understanding that the VM IP address will bounce between the two IP addresses, which is part of this pool upon migration. However, from the service perspective, the incoming sessions will be not impacted because at the end it's live migration. That ends the demonstration.